Hello, everyone. We are here to talk about how you can proactively monitor the health of your business using Amazon Lookout for Metrics that helps customers stay on top of the metrics that they care about. My name is Ankita Verma, and I lead product management for Amazon Lookout for Metrics. With me today, I have Chris King, Senior Solutions Architect for Lookout for Metrics service. In this presentation, I'll talk about how accurate and timely anomaly detection is essential yet a challenging task for businesses today, and how Amazon Lookout for Metrics can help you close the gap. I'll then hand it over to Chris for a quick demo of the service. In the end of the presentation, I'll present to you the resources for you to get started. 2020 was a hard year, and we see more and more businesses moving online. And in this virtual world, it becomes even more important for businesses to stay on top of anomalies or unexpected changes in their data. Anomalies or these unexpected changes in data could indicate an underlying issue, for example, a sudden dip in revenue or a sudden spike in latency of your e-commerce website, which is preventing your customers from making purchases online. These anomalies could also point to an untapped business opportunity, like a new sales category or a new potential customer base that wasn't under your radar. Both these scenarios require you as a business to respond immediately, as delays could cause millions of dollars, missed opportunities, or worse still, losing the loyalty and trust of your customers. Today, the problem of anomaly detection becomes even more critical and challenging as businesses produce more and more data than ever before via multiple sources like mobile, desktop, clickstream. When I talk to customers about their data, most attest to having a business intelligence tool in place that creates reports, dashboards, and track their metrics or key performance indicators. However, they speak to major pain points or gaps that go unaddressed with these traditional monitoring tools. Let's look at some of these closely. The first is the problem of scale. As we discussed in the previous slide, in today's world, businesses have millions of metrics to track across multiple data sources. Take digital ads, for example. You want to track metrics like impressions, clicks, revenue, shopping cart metrics across campaign ID, product categories, geographies, you name it. And it's the same for any domain, be it retail, telecom, gaming, fintech. With traditional BI tools, managing data across disparate sources, creating dashboards, reports, alerts at this granular level is very manual, and it requires maintenance and unautomated work. I speak with a lot of customers who have reporting teams in place with dozens of people creating ad hoc multiple reports on demand. The next big challenge is the problem of alert fatigue and missed anomalies, which simply translates to inaccurate results. These traditional tools work by setting up rules. You set up a range, data points within the range is considered normal, and anything outside the range is an anomaly, and you're alerted on those. If this range is too broad, you miss important alerts. And if it is too narrow, you end up receiving too many false alerts. These ranges are also static and don't change based on time of the day of the week, or seasons. And they need to be manually updated frequently. So you miss important anomalies and receive too many false alarms, which wake someone up in the middle of the night when nothing important happened. So what ends up happening is that you lose trust in the tool and start ignoring these results altogether. The next challenge is the problem of delayed detection. These reports and dashboards are often generated end of hour, end of day, or end of week when it is too late for you to act. And finally, these results are not actionable enough. Even when these results come, it doesn't answer the why. So, developers, analysts, and business owners on your team can spend weeks trying to identify the root cause of the anomaly, delaying meaningful action even further. Now, let's talk about how we use anomaly detection at Amazon. Amazon is a global company with multiple businesses, and these businesses generate a lot of data. For example, Amazon.com sells millions of products across 180 plus countries. These product listings generate billions of clicks and impressions across several hundred million customers, multiple devices, software versions, and marketplaces. We see similar high volume data within AWS services as well. For example, DynamoDB alone generates several hundred millions of metrics daily across thousands of hosts. Accurate anomaly detection to stay ahead of issues and deliver a good customer experience is a problem we have been solving since the very inception of Amazon. Now let's take a look at how anomaly detection evolved at Amazon as its business grew. We started with traditional rule-based approaches and dashboards as early as 1995. Around 2007, we started to incorporate machine learning techniques heavily for anomaly detection. ML allowed us to use all of our historical data and broader context to learn our business cycle. For example, treating spikes in sales during holiday seasons, Black Friday, or Prime Day as norm rather than anomalies. We continued to invest in machine learning and started incorporating deep learning techniques around 2015. We saw a step function improvement in our accuracy because models were now able to dynamically adapt to specific data characteristics like sparsity, irregularity, spikiness, among others, leading to fewer false alarms and reducing our time to resolution. As we introduced anomaly detection capabilities in QuickSight, CloudWatch, and Kinesis data analytics, we also learned that customers need to know the why in addition to the what. We have been working on root cause techniques to answer the why and make the anomaly results more actionable for the customers. In parallel, we continue to invent new ways to match the scale of data generated within Amazon. These experiences have led to several learnings on our end. Our biggest learning based on experiences with anomaly detection across multiple businesses within Amazon is that machine learning-based techniques perform well, but need to solve multiple complex problems. First, customer data is unique, and one single anomaly detection algorithm might not fit all data types and wide variety of metrics that your data has. So your metric set might require a hyper-customized treatment. Second, generating actionable results at scale by learning relationships across customer metrics is critical to faster remediation, yet a very challenging problem to solve. Third, being able to dynamically adapt to changing business cycles and seasonal trends help reduce false alerts, resulting in improved accuracy. And finally, building accurate and effective anomaly detection requires ML expertise, which is expensive and challenging to set up. Amazon Lookout for Metrics, a new fully managed machine learning service that takes all the learnings from anomaly detection at Amazon and puts it into the hands of everyday developer. The service will help you detect anomalies in virtually any time series metric and determine their root cause with no ML experience required. Getting started with Amazon Lookout for Metrics is easy. You can connect your data to the service via any supported data source. The service will automatically and continuously ingest your data, use machine learning to learn the normal behavior of your data, and accurately detect data points that are outside the norm. It then creates an impact summary to help you diagnose the criticality and root cause of the anomalies quickly. Once anomalies are detected, you can investigate the results on the AWS console, consume them via your APIs, and create custom notifications and actions via an output channel of your choice. Amazon Lookout for Metrics also allows you to provide feedback and tune the system for continuous improvement. Now let's look at the benefits of using the service. Here are some of the key benefits of using Amazon Lookout for Metrics. First is the ease of use. We are able to get data in from most sources that our customers care about. This includes popular AWS sources like Amazon S3, Amazon CloudWatch, RDS sources, and Redshift, and SaaS applications like Salesforce, Marketo, among others. It is easy to get your data in without upfront work. Once anomalies are detected, you can send alerts across multiple channels like Amazon SNS, Slack, Datadog, create a webhook channel, or automatically trigger predefined custom actions using AWS Lambda. Second, highly accurate anomaly detection. Amazon Lookout for Metric detects anomalies with high accuracy using the ML technology perfected at Amazon. The service uses ML to create models that are customized to your data characteristics, understand your business cycles, and seasonal patterns. What that means is that you receive fewer false alarms and detect nuanced anomalies that are otherwise easy to miss. As you can see in this example, the service was able to quickly identify the two anomalies highlighted in yellow that deviated from your expected seasonal pattern. You could have missed these anomalies had you used traditional rule-based approaches if your static boundaries were too broad, as you can see with the dotted line above. Next, actionable results at scale. Amazon Lookout for Metrics automatically identifies the likely causes of anomalies, groups related anomalies together, and ranks them in the order of severity. It means that you're able to prioritize, diagnose issues, or identify opportunities quickly without having to spend weeks root causing the issue with your BI or engineering team. In the example screenshot above, you can see that the service does an impact analysis, which tells you for your anomaly in revenue, Android phones in USA are the most impacted, and that's where you should focus your remediation efforts on. Finally, continuous improvement in accuracy. The service allows you to continuously adjust and improve the accuracy of your anomaly results. As you can see in the left image, you can provide feedback on the detected anomalies, which the system is able to learn from in real time. You can also automatically adjust your sensitivity threshold in order to detect fewer or more anomalies. In the right image, the customer changes their sensitivity from 75 to 85 in order to receive fewer alerts, or change it back to 65 if they want to increase the number of alerts. Amazon Lookout for Metrics is a general purpose anomaly detection service, so you can detect anomalies on any time series metrics. We have seen customers successfully test the service across the following use cases. Customer engagement metrics like login, clicks, views, purchases, screen time, bounce rates to ensure a seamless customer experience. Operational metrics like latency, CPU utilization, error rates, throughput to proactively mitigate service interruptions. Sales metrics like number of leads, win rates, pipeline coverage, deal size to evaluate business growth opportunities. Marketing metrics like traffic, volume, revenue, churn to detect how marketing campaigns are performing. And these are just a few examples, but you can bring in any time series metric that you care about, and Lookout for Metrics should be able to detect anomalies quickly. Now I'll hand it over to Chris for a quick demo of the service.
Thanks, Ankita. I'm Chris King, a senior solution architect here at AWS, focusing on Amazon Lookout for Metrics. In this demo, I'll cover a lot of the topics Ankita just shared via this PowerPoint presentation, but dive into more specific details with the service. So to get started, simply visit your AWS console and search for the Lookout for Metrics service. I've actually opened it here in another tab, so I'll switch over to that. And when you join the page for the first time, you'll be greeted with this orange button asking you to create a detector. A detector is the effective model that you're going to be building that will detect anomalies and deliver those alerts later. So to get started, you'll simply click Create Detector. The next thing you'll be prompted to do is provide a detector name. Anything is really fine here. For the purposes of this video, I'll be using a lot of sample values. And it's important to start thinking about your data as well as the interval that it's arriving. The way Lookout for Metrics works is it gathers time series data and then performs anomaly detection on it periodically. So in this case, our data is hourly, so I'll click the dropdown and select 1 hour intervals. You can also provision your data in 5, 10-minute intervals, 1 hour, or even daily. Additionally, if you're really interested in using things like Amazon KMS to manage your encryption keys, you can choose this here, but the service by default will generate a key and keep your data secure and private at all times. The next step is to scroll down and click Create. Once this is done, you'll see this nice flowchart here kind of outlining the steps to operating the service. Once the detector is created, the next thing to do is to add a data set to the detector. Then activate it, which is training the model, and at that point, it can actually start detecting anomalies. And finally, there's an optional step to add alerts to notify you via third-party services, such as Datadog if you wanted to deliver something with a webhook, or first-party like Lambda and SNS. For now, I'll click Add Dataset. So with this, again, we'll provide some sample values here. You can obviously come up with something that's a bit more relevant to your process. And we get to define a time zone first. Right now, again, for demo purposes, UTC is totally fine, but you'll just simply pick the time zone that's appropriate. Scrolling down, you now will see the most important screen or important choice you'll make, which is the data source. So for this, we can see there are a few options: Amazon S3, CloudWatch, Redshift, Aurora, as well as the rest of the RDS suite of databases, and finally, third-party services that are brokered via Amazon AppFlow. You can connect any of these with Amazon AppFlow, and it'll start grabbing those data points periodically, bringing it into the service. But what we'd like to do is focus on the native connectors with Amazon S3 for the rest of this demo. Something else to point out, these database connectors are for getting data outside of the database or out of the database and into anomaly detection. So think about the records you're storing in the database. That is the type of content you can uplift and do anomaly detection on. If you're thinking about metrics about your database, such as query performance or anything like that, it's better to broker those metrics into CloudWatch and then use the CloudWatch connector. But to get started, we're just going to use the sample data set and we're going to upload it into Amazon S3. It's actually already been done for me, but I'll click Amazon S3 as our data source option. And with that, we're now presented with two choices: a backtesting mode and a continuous detection mode. In many cases, when you're exploring the service, I highly recommend starting with the backtesting mode. It allows you to build your data set first, understand the data you're providing to look out for metrics, and then look at actual anomalies it may have identified in previous points in time. This can be really helpful to kind of identify and correlate any anomalies that you've actually seen in your business so that you can validate what the service may be doing for you. To be a little bit more thorough, in this demo, we're actually going to configure the continuous detector, and this is what you would consider for production. So this is making sure we have, optionally historical data, as well as data coming in live into the future that will detect anomalies as they occur. So we'll start with the continuous detector option. And the very first thing that we're prompted for is a path to an object in our continuous data set. So behind the scenes, we need to have a procedure in place that is going to go into an S3 bucket and actually provision a file according to a time series structure so that we can wake up, know where to find our data, and then know what data we're identifying. Bring that data in and detect anomalies on it. And in this case, we've highlighted here kind of in the background what something might look like. So we see we have S3, a particular bucket name, a prefix folder, any folder name will do. And then we start to see time series strings here. So it looks like we're seeing a year, a month, a day, potentially 2 digits for the hour, 2 digits for minutes, and then a particular file name that ends in .json. The file name itself, not really important, and we do support JSON lines data as well as CSVs. What is important, however, is this folder structure. This folder structure is what tells Amazon Lookout for Metrics how to find that information. And so deciding something that's relevant for your business and your problem and making sure that you establish that pattern is critical as your first step. To showcase what my data set actually looks like, I'll first go into S3 where I've uploaded it. And we can see we have this e-commerce data set here. Now, because it's a sample data set, I not only have some historical data points, I've also imagined what a few data points might look like in the future. So if I open this, we'll now see a backtest file. This would have been what we might use for the historical detector, as well as live. So this is our continuous mode. I'll click live. I'll then select a random date, just kind of any one of them, a time slot, and one of these particular files here. So what we'll do now is copy the S3 URI. This is the address to this particular file, and we'll use that in the console to identify what pattern we're using. So we'll come here and we'll now paste it. And what's going to happen is JavaScript running in the console is going to look at this and try to reason about what time series structure we're using. So when I click this dropdown, we'll see a few options. These, I can decide which one I'm actually using for my time series data. It happens to be the third one, so I'll select that. The next thing is to define the interval again for this data that we've provisioned. It happens to be hourly, so I'll select that once more. And now there's an interesting parameter. So this is really relevant when you're dealing with external systems that may not be inside AWS or may be coming from other third-party SaaS products outside of Amazon AppFlow. And that's the offset. And what we mean by that is the amount of time that we should wait before beginning anomaly detection. So let's say you have a process that takes 15 minutes to aggregate all your metrics for the past hour. Then you could simply find out what's 60 times 15, because it's asking for this in seconds. Provide that value here, and then the service will simply wait that amount of time. And you can actually go all the way up to 24 hours for a delay period. Again, using a sample data set, not required, so I'll leave it blank. And the last option here is to use historical data. So we will enable this, and if you have historical data, it does need to be structured the same as your live data, but it will allow the service to read in the data points, train a model faster, and start detecting anomalies sooner. So with that, I'll now go back to my sample data set in S3. I'll go to my backtest file, and I'll grab it as my input. The next few questions are simply about your data. It is in CSV in this case. We do have a header row. It's delimited by comma. We're using quotation marks that are double quotes. We have not compressed it. And now we need to define permissions for this particular service role. So allowing Lookout for Metrics to reach out to S3 and do things on our behalf. So to do that, we'll click Create a Role. And now we need to define the bucket name that we want the Amazon Lookout for Metrics service to have access to. So I will go into the S3 console, and I'll grab this bucket name, and I'll come back here and paste it. And I will hit Create a Role. At this point, the service now has permissions to go read that bucket, find all my data, and start showcasing anomalies within it as it understands and builds a model. Before we go on, though, discovering more of the data, it's helpful to take a look at what we're actually providing. And so I've pulled the data up here. This is the backtesting file that we just pasted in. We see we have a few headers: platform, marketplace, timestamp, views, and revenue. And these all describe our data set. So the platform is the particular device that the user may be using, such as PC with a web browser, or maybe mobile with a web browser. Marketplace is the geographic region where the transaction's occurring. We also have timestamps, and then views, the total number of views for a particular product or marketplace, and the total amount of revenue generated. So this is a synthetic kind of sample e-commerce data set that we're using. With this, now it's helpful to go back and start mapping the data into the service. So we'll hit Next. It's going to validate it can connect to the data source, everything's fine, and now we'll hit OK and go forward. Amazon Lookout for Metrics breaks your data down into two particular types of information: measures and dimensions. A measure is the numerical attribute that we want to do anomaly detection on, and dimensions are categorical fields to help better understand the data set. So if we go back to our original view here, we can see that we have these as categorical attributes, platform and marketplace, and views and revenue as the numerical data sets. So with that, we'll choose for measures that we would like to use views, and we would like to use revenue. We'll choose to aggregate them by sum. It really doesn't matter here because our data is hourly, but we are asked to define an aggregation function. But if, for example, you were feeding data in every 5 minutes and you were detecting hourly, you could choose how to aggregate that information here. The next is dimensions, which for us, again, are platform and marketplace. And lastly, we need to select our timestamp, which is simply timestamp. And to make things easier, we've used this exact timestamp format that's here in our data set, so we can simply copy and paste it. And now we're ready to move on to the next screen. So we'll hit next. We'll review all the things that we've configured, scrolling down, and hit save and activate. And when we've done this, it's actually going to start training a model immediately for us. And here we'll hit the activate button. So this process can take anywhere from 25 minutes to maybe a few hours, depending on how much data you're provisioning into the service first for it to build your model. In this case, with the sample data set, I've seen it usually take around the 30-minute mark. But once that's done, it will start waiting for new data to come in and then detecting anomalies on it. So that can take a while, especially checking data every hour. So to continue on with the demo, what I'll do is go back to my other collection of detectors and select one that was provisioned before. So I have this developer live detector and sample detector. I'll choose the sample detector. And for that, I will then go and look at the anomalies that may have been identified. And here we see things that we also saw in Ankita's screen earlier, this severity score. And with this, it starts at a default of 70. So we're only seeing anomalies that cross that threshold in some way. And the threshold, you can think about the severity score is a ratio of a few things. One, how many times an anomaly is occurring in a particular window of time. So let's say you have 5 products and 4 of them are exhibiting it. That's a pretty significant anomaly. And it's also a function of how deviant that predicted value or the actual value is against the predicted value. So if it's a small trigger and it's not really impacting very much, very, very small severity score. But if, let's say, it was supposed to be 100 and now we're seeing something that's 0 and that's way outside of the range, then that might increase the severity score. And it's really up to you to look at the severity score and decide, how critically do you want to be notified of these alerts? And in this case, you're actually browsing all of the alerts that are detected or the anomalies. So you can kind of move this back and forth to adjust the range and start seeing anomalies that were far less severe. Just for example, though, we'll actually take a look at one which showed that views were impacted. And we'll take a look at it and see what the anomaly itself was. So here we see our severity score. We see that it only took place in the UK and it only involved PC web browsers. And now we can go look at the actual metric. And we can see if we scroll back, we had this nice kind of seasonal curve. But here we actually started to exceed that curve and go well beyond it. So this was simply the first point that started this trajectory. So we could decide, maybe this actually wasn't an anomaly. Maybe this was totally fine. And we can click no. And what that's going to do is create a labeled data point that in the future, it'll decrease the likelihood that we see this in terms of anomalies in the future. However, we can certainly click yes. And it'll be like, you know what? I really want to hone in on this. And I'll start detecting anomalies that are more like this more confidently. The other thing that you can do is to create an alert. And so an alert will actually look at the severity threshold that we define here and then notify your system of choice that an anomaly has occurred with a large amount of JSON that describes the anomaly. So you can learn more about it from that context. With the alerts, you can come here and click add an alert. We'll give it a sample name. You can define the threshold. Again, it starts at 70 as a default. We'll just click a few down. And now you get to decide the exact channel you're going to deliver it on. So I'll use Amazon SNS, for example, here. And now we can choose a topic. I happen to have this alert lookout topic already defined, so I'll select that one. And now I'll choose to create a new role. And it does want me to paste in the topic name. So what I'll do is I'll cancel that, and I will create a new topic. That way I can type the topic more easily. We'll create a topic. All the default options are fine, so we'll hit create. Oh, it must end in 5. Oh, we'll just do a standard one instead. And we'll hit create. And now we'll copy the name of this and go back to look out for metrics. And if we refresh, it should be here. So now we have this lookout metrics topic. And we will create a new role, paste it here, hit create. And now we can hit add an alert. And so anytime an anomaly is defined or found in our data set, it's going to trigger that SNS topic and deliver the alert there. And so any webhooks that we'd like to go on after that can be automatically notified. And that allows you to kind of create these really tight connections with third-party services as well. And with that, thanks for your time. And I'll hand it back to Ankita.
Thanks, Chris, for that demo. You can get started by accessing our product page, developer guide, and GitHub resources, where you can collaborate with other developers as well as members of our engineering and solutions architect team. You can also reach out to the AWS Solutions Architect dedicated to your account to brainstorm use cases, test the service with your own data, and understand how it works in the context of your business. We also conduct training workshops and hackathons for practical education on ML. So this brings us to the end of the session. Thank you everyone for tuning in. We'll now move over to Q&A.